The vacuum unit is usually considered to be part of the crude unit complex. One limitation that the crude unit has is that crude oil can only be heated to about 700 degrees Fahrenheit before it starts to crack to undesirable materials. Since the crude unit operates at atmospheric pressure, that limit is reached before all the valuable material can be successfully separated in the crude tower. However, it is well known that the lower the pressure, the lower the temperature that a given material boils at. Therefore, one way to recover that valuable material, which can't be recovered in the crude unit, is to perform the distillation at reduced pressure. This will allow the refiner to separate out gas oil streams to be used as FCC feed from lower value coker feed. Material that cannot be vaporized in the crude tower at the crude furnace outlet temperature falls to the bottom of the crude tower. That material is then fed to the vacuum furnace where it is partially vaporized. The vacuum tower uses the Venturi principle of a steam ejector in order to pull a vacuum. This is a converging divergent nozzle where the velocity of the steam increases as it moves through the middle or restricted area of the nozzle. This causes the pressure to decrease in accordance with Bernoulli's principle. A typical vacuum pressure is 10 millimeters of mercury. This is as opposed to 760 millimeters of mercury when operating at atmospheric pressure. How low a vacuum that can be reached is directly proportional to cooling water temperatures. The lower the cooling water temperature, the lower the vacuum. Providing additional cooling for the steam condensation system for the vacuum tower is the most important Aggreko application. As vacuum tower pressure rises, the amount of HVGO decreases and the amount of vacuum tower bottoms increases. This is detrimental to refinery economics since the value of HVGO used as FCC feed is much greater than the same material going to the coker. The vacuum tower uses special packing internals to provide adequate vapor-liquid contact due to the possibility of coke buildup. The vacuum tower typically recovers light vacuum gas oil, LVGO, and heavy vacuum gas oil, HVGO, along with the bottoms material which runs down hot to the coker as coker feed. The vacuum tower is similar to the crude tower in that it has pump rounds for heat removal in both the LVGO and HVGO sections. While these products are typically combined together as FCC feed material, they were pulled as separate draws in order to provide better heat recovery since these sections operate at different temperatures. The net result is a smaller vacuum tower furnace.